And the answer is yes, but it's not the shadow. That's the really visually appealing part of this, from the Earth, anyway. This is because the Earth is 4 times as big in the moon sky as the moon is on Earth. So when the Earth fully obscures the sun, the whole moon is in the umbra. At first, the shadow of the Earth creates a crescent shape. Explain that flat earthers. But what is different this way around is that unlike the moon, the Earth has an atmosphere. This means that when the moon is totally eclipsed, the Earth's atmosphere reflects the sun's light around the planet gently, illuminating the moon in a reddish hue. This makes for a beautiful but almost spooky view. The color is caused by R scattering a topic. I've discussed in another video, R scattering is the same process that makes our sky blue and our sunset red. This image is beautiful in that you can see the different wavelengths of light being scattered through Earth's atmosphere from deep red from this side through to blue on this side. From the moon's perspective, none of the sun would be visible during a total eclipse, but the atmosphere on Earth would be illuminated so you would see a ring around it. This is an actual view of a lunar eclipse on the moon by one of the JAXA probes in 2009. It's quite the awe-inspiring sight. The Earth and Moon aren't just getting in the way of each other, either. Here is the Earth eclipsing the Apollo 12 spacecraft in 1969, while it was on its way back home, and here's the Moon getting in the way of the Earth from the perspective of the Discover satellite. Interestingly, this is the side of the Moon you never see as the Moon is tied locked to the Earth, which means the same face is always looking towards Earth. From this perspective, the Moon looks very foreign, but it is indeed a real video of our only natural satellite transiting the Earth from another satellite's perspective. But this time, looking at the Sun with the SDO satellite, the Moon often makes an appearance. The position of this satellite as it orbits the Earth means the Moon can block the Sun occasionally, and here's the Moon again, this time from the perspective of one of the stereo satellites. The Moon isn't the only thing that orbits between us and the Sun. Mercury often transits across the Sun, a tiny minnow compared to the solar system's giant. The next time this will happen is on the 13th of November 2032. So a little while away. You might want to put it in your calendars for now. Venus also orbits between us and the Sun, and as it is much closer to us and bigger than Mercury, its silhouette appears much larger. Its last transit was in 2004 and 2012. But sadly, if you miss those two, chances are that you will never see it. These transits happen in pairs, and then there is a 100-year gap until the next one. In other words, the next transit will be in 2017. This happens for the same reason. The Moon doesn't eclipse us every month. The orbits just don't often align. Still, we have high-definition videos of the last one, and it is quite the sight to music. Behold, moving to another planet. Now we can go to Mars, which has plenty of unmanned robotics, either in orbit or on the surface. Mars also has 2 moons, Phobos and Deimos. They are both pretty small. Phobos is 22 kilometers across, and Deimos is only 13 kilometers across. They both orbit very close to the planet, though. Phobos is only 9,000 kilometers above the surface, and Deimos is 23,000 kilometers, which means, although tiny, you can still easily see them from the surface of Mars, especially Phobos. The Curiosity rover was able to capture a moment where incredibly Phobos eclipsed Deimos. This video is captured in real time and shows the size differences of the moons in the Mars and sky. And this is not all. The Curiosity rover captured, it was also able to see a transit of Phobos in front of the Sun. Due to the distance of Phobos to Mars, it moves across the sky fairly quickly, only taking about 7 hours to orbit. This means that this video you are watching is in real time. And these solar eclipses on Mars don't last for more than about 30 seconds. The surrounding ground does get noticeably darker during an eclipse, by Phobos, as can be seen from the rover's perspective. but it can also be seen from Space Foss's shadow. Here can be seen by the Viking 1 orbiter, and also here more recently by the Mars Global Surveyor. The Opportunity and Spirit rovers have also seen a transit of Deimos, but it appears much smaller. Just a dot passing in front of the Sun. It doesn't cause a noticeable decrease in brightness. Mars is pretty impressive, but that's not all the solar system has to offer. Have a look at this video captured by the Hubble Space Telescope. Looking at Jupiter. Jupiter has 4 large moons, 3 of which at certain points can transit the planet at the same time, leaving 3 big shadows. The moons in question. In this video are Io, Callisto, and Europa. Interestingly, like we talked about before, with the umbra and penumbra. You can see that because Io is the closest to the planet, its shadow is the sharpest, whereas you can see with Callisto, the furthest away of these 3 moons, the penumbra is much larger, causing a blurry shadow. And in this video, how will spies the occultation of Ganem, the largest moon of Jupiter, saw some incredible transits and occultations of Saturn's many moons. Here is one of Epimetheus passing in front of Titan, with Dionlai coming in from the side. This little white dot coming in from the left, just under the ring.